So liquids and solids have definite properties. We've seen that in the gas state, the molecules or atoms are separated by large distances, whereas in a liquid or a solid, the molecules are touchingly close, or the atoms. They're touchingly close, meaning there's more chance for interaction between the particles. What makes a solid and a liquid different is the freedom of movement. In a solid, the molecules or atoms can vibrate, wiggle. So you guys are in the solid state right now, and you're wiggling and moving in your seats. But in a liquid, they can move relative to each other. So if we all got up out of our desks and were walking around the room, that would be like the liquid state. Still close together, still interacting with each other. So we see in gases, lots of space between the molecules or atoms, no real interactions going on. In a liquid, close together, but able to slide around. In a solid, fixed in a rigid order. I'm going to go through these pretty quickly because we've talked about them before. So gases have low densities compared to liquids and solids because density is mass divided by volume. With all that empty space, they have a much larger volume, and so their densities are low. Indefinite shape, indefinite volume. You can compress them, expand them. They take on the shape of their container. This is because they have weak intermolecular forces relative to the amount of thermal energy. Liquids are going to have much higher densities compared to gases. They also have indefinite shape, taking on the shape of their container, but their volume remains constant. You can't compress them. So they have moderate intermolecular forces. Solids, high densities compared to gases, comparable to liquids, again, touchingly close. But solids do not take on the shape of their container. They have a shape and they just keep it regardless of where they are. And they have definite volume. They can't be easily compressed either. How the particles are arranged may vary. They may be crystalline, there's an ordered pattern to them, or amorphous, without shape, disordered. And they have strong intermolecular forces. Yeah, I talked about that. Talked about that too. So here's like an iceberg. And these molecules of water are vibrating, but they're not moving relative to each other, and that's why the iceberg keeps its shape and doesn't just, flow into the ocean.